awak. Awak yang tu lah. Jangan lupa subscribe channel kita. Tanda sokongan. Terima kasih. Assalamualaikum and hi everyone. So welcome back. Jadi dalam video kali ini kita nak discuss lagi beberapa soalan berkaitan dengan chapter 4 work energy and power. Okay, jadi untuk soalan yang ada dekat sini mungkin markahnya 8 sehingga 10 markah. So kita just buat saja sebagai latihan. Okay, so dia akan combine lah semua subtopik menjadi satu soalan under chapter 4. Alright, so jom kita mulakan dengan soalan yang pertama. Okay, so question number 1. So let's read the question first. So here we have a force that acts on an object as a function of x is shown in figure 3. So here we have a graph of force and x against x. Okay, so calculate the work done equal to 0 and less than or equal to 4. So from 0 to 4 basically. So we have a graph of f against x. So we want to calculate the work done by the force. Okay, so kita tahulah kat sini kita boleh kira the area, work done. Okay, the work done is equal to the area under fx graph. Okay, so this is a trapezium shape. So we can calculate half times, okay, the height is 5, okay, and then the parallel side is 2 plus 4. Okay, so this is 2 and plus 4. Okay, so times 5 times 2 plus 4. Okay, and then the answer is 15 joule. Okay, 2 markah dekat situ. And then B. Okay, so here we have a bullet. Okay, 25 gram bullet moving with speed 200 meter per second. Okay, hits a wooden block and stops after penetrating 35 centimeter into the block. Okay, so using the work energy theorem, calculate the average frictional force experienced by the bullet. Okay, so we have a bullet, right? So the mass must be in kg. So 0.025 kg. Alright. And then the bullet is moving with the initial velocity of 200 meter per second. Okay. So let's draw. Let's say this is the bullet. Okay. This is the bullet and the bullet is moving in this direction. Okay. And then what happens? So here we have the wooden block. Okay, so when the bullet entering the wooden block, okay, so the initial speed still equal to 200 meter per second. Alright, and then when the bullet hit the wooden block, okay, what happened? It will stop. Okay, it will stop. Okay, after penetrating 35 centimeter. Okay, so let's say this is the position of the bullet after penetrating the wooden block. Okay, so this is the position. Okay, so the distance here, okay, this is S. Okay, where S is equal to 0.35 meter. Okay, macam mana dia boleh berhenti masa dia sampai dekat sini? V dia kosong. Okay, macam mana V dia boleh kosong? Sebab ada because of frictional force. Okay. And then the frictional force must be opposite direction, right? Okay. Objek itu bergerak ke kanan. So the direction of the frictional force must be opposite direction with the motion. Disebabkan adanya frictional force itulah akhirnya bullet yang bergerak tadi dia akan berhenti kat dalam tu. Okay. So soalan minta kita kira apa? By using the work energy theorem, calculate the average frictional force. Okay. Experienced by the bullet. Alright. So W. Okay, so the work done, okay, by the frictional force is equal to delta K. Okay, disebabkan ada perubahan velocity tadi, so means that ada perubahan kinetic energy. Daripada dia bergerak U dia 200 meter per second until dia stop. Means that ada kerja yang dilakukan, okay, in order to against the frictional force. Okay, the work done to against the frictional force. Alright, so, F, kalau S ke kanan, Fs, S is in this direction, so the angle is 180 degree, right? Okay, so we can write Fs cos 180 is equal to half mv squared minus half mu squared. Okay, and then this is negative 1, cos 180 is negative, fs equal to half. So the mass, we can factorize the mass, 0.025 kg, and then v squared minus u squared. Okay, so negative ni kita boleh cancel. This one. Okay, so ini kita boleh cancel lah negatif ni nanti. Alright, and then finally, frictional force, you akan dapat 1428.6 Newton. Okay, so the frictional force is 1428.6 Newton. Alright, so that one is the answer for B. And then the last one, C. Okay, so let's read the question. A 50 kg box is lifted through a vertical distance of 20 meter in 3 seconds. Okay, so calculate the calculate the power employed. Okay, so means that we have a box here. Okay, so the box, we have the weight of the box W straightly downward. So when the box is moving upward, means that there is a net force, okay, where the direction of the net force is upward direction. Sebab itu dia boleh bergerak ke atas. 20 meter in 3 second. Okay, so F net dia adalah, direction dia adalah ke atas lah. Macam tu. Okay, so it's moving upward direction 20 meter. And then we want to calculate the power employed. So means that power is equal to, okay, so kita buat kat sini lah. So power is equal to the rate of work. So W over T. Alright, so W, we can use equation F net as cos 0. F net dengan S same direction, straightly upward, right? So cos 0 is equal to 1 times T. So F net, okay, in this case, you can see here that F net must be same amount, same value as the weight. Okay, so kita boleh tulis F net kita adalah mg lah. Mg times S over T. Okay, so kita boleh masukkan nilai dia lah. Mass dia adalah 50 kg, 9.81, S is 20 meter. Okay, and then 3 seconds. So power here, I got 3270. Okay, now make sure you try to calculate. So this is the answer. Okay, 3270. So the value of F net, okay, daya bersih ke atas, okay, must be equal to the weight. Okay, F net must be equal to the weight. Okay, next. Alright, question number 2. Okay, so here we have an object. Okay, 8 marks here. Okay, an object of mass 2 kg move at a constant speed of 5 meter per second up a plane incline at 30 degree to the horizontal. So the constant frictional force is 4 Newton. So we want to determine the rate of work done against the gravitational force. So the rate of work done means that power lah. Okay, power to against the gravitational force. Okay, so let's draw the inclined plane first. Okay, let's say here we have the inclined plane. And then here we have a box. Okay, let's draw the box. Okay, and then this is 30 degree. The angle is 30 degree here. So let's draw x-axis and y-axis. So the y-axis. Okay, and this is the x-axis. X-axis tu mesti parallel dengan surface dia ni. Yang saya highlight warna kuning tu. Okay, and then we're going to have weight straightly downward. Okay, and the angle here is 30 degree. Okay, and then kita akan ada normal force as usual. So if the object is moving upward, dia bergerak naik ke atas. Okay, constant speed dia dah bagi kat situ. Okay, moving in this direction. V is equal to 5 meter per second. Okay, means that the frictional force must be opposite direction. Alright. So, if you want to resolve W into WY and WX, okay, doesn't matter. So, you can resolve W into WY and then you can resolve also into WX. Okay. So, now for question A, so we want to calculate the power, okay, the rate of work done, okay, to against the gravitational force, means that P is equal to WG is the work done, okay, to against the gravitational force, alright, over T. So WG, tengok dekat sini weight dia, okay, the weight in this case, you boleh buat dua cara lah. Sama ada you want to look at the angle, okay, between W and S. Okay, so maknanya dah akan macam ni lah. So let's say this is the X component and this is the Y component. So W straightly downward. So S dia ke sini. So means that the angle between W and S, okay, bukan WY, W. So 30 plus 90 degree. So the angle is 120 degree. Or you want to resolve W into WY and WX. So when you resolve W into WY and WX, we must choose a force that is parallel with the displacement. So you can see here that WY, okay, dia punya direction S dia adalah in this direction lah. So the direction of S is in this direction, naik ke atas. So dia adalah 90 degree. So S ke atas, W ke bawah 90 degree. So we cannot choose force that is perpendicular to the displacement. So we choose WX. So if you want to choose WX, so the angle between WX and S. Okay, so look at here. S is in this direction. Okay, moving upward. And then the WX is opposite direction. So 180 degree. Okay, so the angle between WX and S is 180 degree. So it's up to you. If you want to find the power, okay, power to against the gravitational force. So if you choose W, so means that, okay, the work done by the gravitational force, dia akan jadi WS. Sebab kita pilih W kan. So W ini. Okay. So angle dia adalah 120 degree. So WS cos 120 degree. Formula work. Ingat remember again, W work formula dia adalah Fs cos theta. So force kita kat sini adalah the weight ataupun the gravitational force. Okay, merujuk kepada weight objek tersebut lah. Sebab itu kita tulis W. Where W is equal to mg. Okay, over T. Okay, so kita masukkan nilai mg as cos 120 over T. So, tapi soalan tak bagi kita nilai S dan juga time T. But, here we have S over T. So, remember S over T is equal to V. Therefore, we can find P is equal to mgV. Okay, mgV cos 120, where the mass is 2, G is 9.81 times S, okay, times V, S over T adalah V lah, times cos 120 degree. Okay, so you akan dapat jawapan lah. P dia dekat sini, you akan dapat negative 49.1 watt. Okay, so why negative? So why here we have the negative sign? Okay, because negative means that the rate of work done to against the gravitational force. Okay, maknanya untuk dia bergerak naik ke atas ni, okay, kita perlu melakukan kerja untuk melawan gravitational force ni, iaitu berat dia sendirilah. Okay, kalau kita nampak, kalau kita resolve, kita ambil WX ni, WX is opposite direction with V. Okay, so means that the negative sign is the rate of work, okay, work done to against, okay, to against the gravitational force. Okay, tengok tulislah. Okay, and then B, Okay, B, the rate of work done against the frictional force. Sama juga. P, so work F. Okay, work done against the frictional force. Okay, so kita tahu frictional force opposite direction with the motion lah. So dia akan jadi 180 degree. Okay, so dia akan jadi Fs cos 180 degree. Equation work. Force kali ni kita pilih F lah, friction. Work done against the gravitational force. Sorry, work done against the frictional force over T. Okay, sama juga. S over T is V. So P is equal to friction 4. V is equal to 5 cos 180. So the answer should be negative 20 watt. Unit jangan salah. Sama juga kita dapat power dia adalah negatif. That means this is the rate of work done. Okay, maknanya rate of work done. Jadi kalau sistem tu dia nak bergerak, dia perlu hilang. Okay, dia perlu membuat kerja. Okay, ataupun hilanglah energi. Maknanya dia punya W work dia akan dapat negatif. Kalau kita nampak dekat sini, W dia, nilai W dia adalah negatif. So kita tahu kat sini bila work dia adalah negatif, means that work done by the system to against the frictional force, means that energy akan loss lah. Okay, so rate of work done against frictional force, kita akan dapat negatif. Jadi untuk objek itu bergerak, okay, kita perlukan power supply. At least power supply dia mesti sama lah. Maknanya kita tahu okay, power kita dapat negatif ni, maknanya power yang diperlukan lah untuk objek itu bergerak. Therefore, in order to answer question C, the power supplied to the object. So kita dah tahu dah energi akan digunakan nanti untuk melawan dia punya frictional force dan juga dia punya gravitational force, berat dia sendiri. Okay, jadi power yang diperlukan, okay, power yang diperlukan ataupun power supplied to the object must be power needed, okay, ataupun the power needed to against the gravitational force tadi, okay, iaitu kita letaklah power apa, power G plus power needed to against the frictional force. Okay, so kita tambahkanlah 49.1 plus 20, kita hilangkanlah negatif tu, kita nak dapatkan berapa nilai power supply tu. So the answer is 69.1. Okay, alright, so this is the answer for question number 2. Alright, question number 3. So here we have question 3A, okay, where here we have 2 marks for 3A. And then we have 3B, 4 marks, conservation of energy. Okay, this is under subtopic conservation of energy. And then we're going to have 3C about average power and instantaneous power. Okay, menariklah ni, kita ada 4, 5, 9 markah, 10, 11. Okay, lebih kurang lah Okay, so kita tengok dulu bagaimana kita selesaikan soalan 3A untuk dapat 2 markah ni. Alright, so let's read the question. So force F of magnitude 10 Newton, okay, and the friction force of magnitude 3 Newton. So means that if the object is moving to the right, okay, it's moving to the right, so the frictional force must be opposite direction. Okay, so the question is calculate the work done on the box if it is displaced 2 meter. So means that S is equal to 2 meter. Kita ada dua lah, kita nak kira total work done kan, ataupun W net. Okay, means that work done by the external force plus work done by the frictional force. Jadi bila you nak kira work done by the external force, okay, you can straightly ambil lah angle F kat sini, S in this direction. So, you akan dapat terus 30 degree. Tengok So, nanti you punya work done by the external force, dia akan jadi Fs cos 30 degree. Okay? Atau ada yang kata, boleh tak saya nak resolve? Yes, you can. So, here we have Fx and here we have Fy. Jadi, Fx ini adalah F cos 30, while Fy is F sin 30 degree. Okay, so you can choose force that is parallel with the displacement S. So in this case, yang parallel adalah Fx. So you tengok betul-betul S is in this direction to the right. Jadi Fx pun sama to the right. So angle antara mereka ni adalah 0 degree. Okay, so pilihlah you nak kira cara yang mana. You nak kira cara yang, so dia akan jadi macam ni lah. Yang hijau ni dia akan jadi WF. Dia akan jadi Fx S cos 0. Jadi Fx ni kena gantikanlah dengan F cos 30. Okay, so jawapannya akan sama juga. Okay, tapi kalau kata you nak pilih yang ini, you nak ambil terus angle dia, boleh juga. Tak ada masalah. So dia akan jadi F S cos 30 plus, and then the frictional force. Okay, what is the angle? Friction pergi ke kiri, S ke kanan, so angle mereka 180 degree. So plus friction S cos 180 degree pun boleh juga. Okay, so yeah, we just substitute all the values. Okay, you masukkan sajalah nilai dia tu. Nanti you akan dapat 11.3 joule. Tapi kalau kata nak guna cara yang resolve ni, kan, Fx dan Fy, and then you choose Fx, pun boleh juga. Okay, so dia akan sama jugalah. Ataupun, okay, saya buat kat bawah ni you nak buat juga pun boleh. So dia akan jadi W, F ini kita akan pilih Fx lah, plus friction. So dia akan jadi Fx S cos 0. Sebab apa? Fx dengan S tu parallel, plus friction cos 180. Tapi jangan lupa, ini adalah Fx, bukan F. So dia akan jadi Fx awak akan jadi F cos 30 darab dengan S. So cos 0 is equal to 1 plus cos 180 negative 1 negative Fs. Sama juga nanti you akan dapat jawapan 11.3 joule. Unit jangan salah Boleh Okey. Itu je kot. Tak ada dah lagi. Itu je yang dia tanya, 2 markah saja. Alright. So, let's proceed to 3B. Sorry, this one, 3B. Alright. So, this is about conservation of energy. So, here we have a block. Okay, 4 markah A block of mass 0.1 kg. Okay, so here we have a mass of 0.1 kg. Okay, is placed at point A. Okay, and the position of the block is at height of 3 meter. And then the block start to move with an initial speed of 3 meter per second. Okay, maknanya mungkin dia bergerak dari sini lah kot U dia. Okay, so dia dah ada U is equal to 3 meter per second. Alright, and then the height, okay, so when the object is at certain height, means that the object has the gravitational potential energy. Okay, so dia ada UG. UG tu dia ada gravitational potential energy masa dia dekat point A. Okay, and then dia bergerak dengan initial velocity. So maknanya dia ada kinetic energy. Ini cerita masa dekat point A. Okay, energy yang dia ada. And then what happened to the block? It travels down the slope and finally compress the spring. Okay, you can see here. So the object will move until it compress a spring at point B. And then the first calculation determine the maximum compression, okay, by the spring. Okay, so maknanya kita nak kira compression dia X lah. Berapa kita nak kira? So bila objek, okay, bila spring compress, so dekat point B dia mesti ada elastic potential energy. Jadi bila spring itu compress secara maksimum, objek itu tidak bergerak lah. Dia dah maximum compression. So pada keadaan ini V dia adalah 0. No velocity. So no kinetic energy. So at point B dia hanya ada apa? Dia hanya ada elastic potential energy. Okay, so energy yang dia ada masa awal tadi dekat point A, iaitu gravitational potential energy and kinetic energy, dia jatuh turun ke bawah dan energy itu, okay, digunakanlah untuk dikompreskan spring tersebut. Okay, so dia akan tukarkan energy tadi kepada elastic potential energy. Boleh Okey. Jadi sekarang kalau kita nak jawab soalan yang pertama, we use conservation of energy means that in a closed system, total energy masa dekat point A sama juga dengan total energy at point B. Okay, so at point A, we have gravitational potential energy plus kinetic energy. And at point B, we're gonna have half kx squared, iaitu, kita tulis US dulu. Okay, elastic potential energy. So, you masukkan semua nilai. And then finally, you boleh carilah maximum compression of X. We want to find X here. Okay? So, substitute all the values. So, the mass of the object is 0.1 times 9.81 and the height is 3 meter plus half and then times 0.1 times V. So, the initial velocity tadi dia dah bagi 3 meter per second squared. Okay? Jangan tertinggal lah squared tu. Equal to half. The spring constant is 500 x squared. Okay? Therefore, x you akan dapatlah 0.12 meter. Okay? So, this is the answer for number 1. Okay? Finish that one. And then second part, if a stiffer spring is used, explain what will happen to the maximum compression. So, bila soalan sebut stiffer spring, okay, means that the spring constant K, okay, the spring constant K is bigger than 500 Newton per meter. Maknanya kalau stiffer spring tu maknanya nilai spring constant tu besar lah. So kalau kita tengok pada soalan ini, pada equation ini, okay, sebab soalan tanya what happened to the compression X. Okay, if K is bigger. Tapi, tengok kat sini yang depan ini tidak berubah. Ketinggian dia masih sama. mgh. Plus, and then dia tak bagi tahu pun dia punya initial velocity, dia berubah kan? So, dia masih sama lah. UG plus KE ni masih sama kat sini. Yang berubah dekat sini. So, kalau saya tulis balik equation, okay, so dia akan jadi mgh plus half mv squared equal to half kx squared. Okay. So, kalau k ini, tengok sini if k, what happen? If k is increasing. Kan? If k is increasing, so let's use another color. Besar kan? So, ini constant. Ini tidak berubah in this case. Dia tak ada ubah V, tak ada ubah height. Okay. So, kalau kita nak tahu x kita, kita boleh tulis balik lah. Kalau nak tulis, dia akan jadi 2 times mgh plus half mv squared. Is it? Bagi dengan k lah. Square root. So, kita tahu kat atas ni tadi constant. Okay. Jadi, kalau kita guna k is increasing, what happen to x? Okay. The compression akan jadi lebih kecil. So, kita boleh tulis therefore, maximum compression. If you use stiffer spring, the maximum compression, okay, becomes smaller. Okay, so this is answer for 3B. Alright, question 3C. So here we have a stationary bus, okay, of mass 2,500 kg starts to accelerate with a constant acceleration 1.5 meter per second squared. Determine the average power produced by the bus engine if the bus reaches a speed of 12 meter per second in 8 seconds. Okay, keluarkan semua maklumat dulu. 2,500 kg. Okay. And then the acceleration is 1.5. Okay, apa lagi dia ada? So, dia bagi tadi dia punya start from rest, stationary bus. But V is increasing to 12 meter per second. And the time taken to increase the speed is, 8 seconds. Okay, so the average power P is equal to W over T. So we just use this equation. Okay, W. So you can see here we have a change of velocity daripada 0 kepada V. So when we have the change of velocity means that there is a change of kinetic energy. So we can use the work energy theorem W equal to delta K over T. So kita boleh terus tukar delta K lah. Iaitu K final half mv squared minus K initial half mu squared over T. Okay. So the mass you can see here, kalau ini you nak cancel, then you can cancel lah, you kosong kan. So half, mass is 2500 kg, and V tadi dia dah bagi tahu dah, dia increase. Is it? V is increase 12 meter per second dalam masa 8 second. So power dekat sini kita akan dapat 2.25 times 10 power of 4. Unit dia adalah watt. Okay, so ini jawapan lah. And then number 2, the power of the bus engine at T is equal to 5 second. So untuk jawab soalan number 2 ni, dia sebenarnya tanya instantaneous power. What is the power at that moment, at that time, where T is equal to 5 second. So, kita boleh guna formula instantaneous power, which is equal to FV, FV cos theta. So guys, so let's say this is the bus. Okay, we have a bus here, and it is moving in this direction. So dia akan ada F net dia lah. Okay, in this case F net here, this is the F. Okay, so you can see, we can write that total F net is equal to MA. So you can ganti dekat sini, MAV, and then direction, sorry, the angle. Tengok direction F net ke kanan. So V dia pun dia bergerak ke kanan lah. So cos 0. Okay. Cumanya dekat sini, kita ada semua nilai. A, M, cos 0, 1. But this time, we don't have value of velocity. So what is the velocity? Okay. Ni saya tebalkan sikit. So what is the velocity at T is equal to 5 second? Kita tak tahulah. So, kita boleh kira. Okay? So, kita boleh kira V dekat situ. Macam mana kita nak kira? Maybe you can use equation V is equal to U plus AT. So, at T is equal to 5 second. Okay? So, A awak tadi dia dah bagi 1.5. Alright? And T, so T we times 5 second. Betul tak? Okay, 5 second. So, dekat sini saya dapat V saya adalah, cuba kira lah, 1.5 times 5. 7.5. Okay, 7.5 meter per second. Okay, and then, you can find what is the instantaneous power. Okay, and F equal to MA. So, the mass of the bus times the acceleration 1.5 and times V is 7.5. Okay, cos 0 is equal to 1. Okay, finally, you akan dapat jawapan 2.81 exponent 10 power of 4 watt. Unit tu jangan salah. Okay, so finish question number 3. So, let's proceed to question number 4. Alright, question number 4. So, here we have 2 parts. So, for A, we have 4 marks here. And then, we proceed to 4B. So, here we have 4B, which is 6 marks. Okay. And that's all for this video. Okay. So, let's start with the first question. So here we have a vertical spring, ignore its mass, which spring stiffness constant is given with 950 Newton per meter. It's attached to a table. The spring is compressed down 15 centimeter and 0.3 kg ball placed on it. The spring is then released and the ball flies off vertically. So determine the speed of the ball when it lifts the spring. So lukis dulu, baca je. Kan kita pening nanti, so kita lukis dulu. Ni macam tu kan. Okay, so let's say this is the spring. Dia kata apa tadi? The spring is compressed down 15 cm. Ada bola, letak dekat spring. Spring tu compressed. So kat sini lah bola dia. Kan? Okay. And then soalan suruh kita determine the speed when the ball leave the spring. Maknanya pada ketika dia nak bergerak tu lah. So bila bola itu dah mula bergerak nak naik ke atas, meninggalkan spring tersebut, maknanya dia telah kembali kepada bentuk yang asal. Ni. Let's say lah asalnya bentuk spring tu macam ini. So kita nak kira berapa V dekat sini lah masa dia nak naik ke atas. Okay. Saya ada discuss soalan spring macam ini dalam video yang sebelum ni, iaitu video conservation of energy about spring only. Okay. So here, let's say lah saya guna method yang kita pilih reference point. Okay, saya ada discuss dalam video sebelum ni. Maknanya saya tanda dekat sini terus. Okay. Saya tak tahu ni berapa panjang ni. Berapa L1. Sini saya tak tahu berapa. Okay. So, untuk memudahkan kita, kita boleh jadikan dia sebagai our reference point. So, kita terus buat macam ini supaya seolah-olah kita dah cancel lah ketinggian bagi kedua-dua keadaan. Iaitu keadaan gambar pertama dan juga yang kedua. Okay. Sebab itu akan lebih mudah lah. And then, kita tengoklah the type of energy. Okay. Sebelum tu, you tengok dekat sini. Berapa pula panjang yang ini? Yang ini. Okay. So, kalau daripada sini, okay, tolak dia punya yang bawah tu. So, ini kita panggil dia punya compression lah. Okay. The length of the compression. Maknanya dia compress sebanyak berapa tu? Kalaulah dia daripada asalnya macam ini, so dia turun ke bawah, so ini dia punya X lah, dia punya nilai berapa dia compress tu. Boleh ini saya guna cara kedua lah. Kalau you nak guna cara yang pertama, boleh. You need to consider L1. You need to consider L1. Okay. So maknanya masa dekat gambar pertama, bukan sahaja dia ada elastic potential energy. Tapi kalau you nak consider dia ada ketinggian L1 tadi, dia mesti ada gravitational potential energy. Tapi kalau kita dah cancel yang bawah ini, kita buang, kita fokus kepada dekat mana dia mula dengan dekat mana dia berakhir. So yang bawah ni, yang purple tu kita ignore. Pun boleh juga. So maknanya kita consider, okay, we let this is our reference point. Kan, ini adalah our reference line. Okay. So maknanya pada gambar yang pertama tu dia tak ada ketinggian. Dia ada elastic potential energy because of compression of the spring tadi. But in picture number 2, so the object start to move, right? So here we have V. And here we have kinetic energy. And at the same time, the object is located, okay, at the position of X. The height is X from the reference line. Let's say this is our ground lah. Reference line. So kat sini dia akan ada kinetic energy. Kalau ini 1, ini gambar yang kedua. Dan dia ada juga gravitational potential energy. Okay. And then by using conservation of energy, 1 equal to 2. Okay, gambar 1 is equal to gambar 2. Okay. So we're gonna have US1 equal to KE2 plus UG2. And then, dia akan jadi apa? Half KX squared equal to half MV squared plus MGH. H dia dekat sini adalah X. Ketinggian dia adalah X sahaja sebab this is our reference line. Kita dah potong ni tadi kan? So, dia akan jadi X. Okay, kalau you tengok video saya yang discuss berkenaan dengan soalan spring sahaja, you akan nampak saya buat dua cara. Okay, method pertama, that's mean we consider length yang L1 tadi tu, yang bawah spring yang kecil tu. Okay, yang bawah ni, sekejap saya tunjuk. Sini, method yang pertama. Method kedua, saya akan potong kat mana dia mula, dekat mana dia berakhir. So, saya jadikan this is our ground lah, reference line. Okay, so therefore, here we have all the values. K ada, X you boleh cari, M ada, X ada. Kan dia dah bagi tahu tu, compression X equal to 0.15 meter. Okay. V yang you nak cari lah, yang lain semua you dah ada. Okay, you masukkan semua nilai tu betul-betul. Masukkan elok-elok. So, kita akan dapat apa? Kita akan dapat, memang saya kira sekali. Half, K is 950. X is 0.15 squared equal to half and the mass is 0.3 kg. V nak cari plus mass 0.3 times 9.81 and X is 0.15. So dapatlah V dia. Okay, tekan kalkulator, you akan dapat 8.27 meter per second. Okay, so this is the answer. Alright, so second, okay, how high above its original position will the ball fly? Okay, so untuk jawab soalan yang kedua ni, saya prefer lukis lah. Okay, jadi untuk jawab soalan fizik, you kena biasakan untuk lukis. Contoh, ini gambar, alamak tinggi sangat Saya buat bawah sikit. Okay, contohlah ini tadi gambar yang kedua. Okay, masa the ball is about to release, dia ada V. Okay, and then sepanjang spring yang sama. Gambar yang ketiga, maknanya ball tu dia dah naik sampai ke atas. Contohlah dekat sini position dia. Okay, dan initial position dia kat sini masa spring tu compress. Jadi soalan minta kita kira from the initial position, daripada sini sampai sini, kan? Okay, boleh tak kita nak guna gambar 1 dengan gambar 2? Boleh kan? Okay, kita boleh guna gambar 1, conservation total energy in picture 1 and total energy in picture 2. So kalau tadi kita tahu ini adalah X. Okay, so kalau you nak ambil you punya reference point, this is our reference point or your reference line. So yang bawah ni you can ignore. Okay, so if you try to solve this problem, so we can use total energy in number 1 equal to total energy in picture number 3. Okay, awak boleh guna macam ini. So dia akan jadi apa? Dia akan jadi dekat number 1 tadi, dia akan ada energy apa? Akan ada elastic potential energy. Ada ketinggian tak? Tak ada, sebab kita dah potong yang bawah ni, kalau orange yang bawah ni. Okay, so kita akan ada US saja. Tapi masa dia dekat gambar number 3, so you can see here, this is the maximum height. So V is equal to 0. Dia dah naik dah ketinggian paling tinggi, maximum height. At maximum height, V kosong, so no kinetic energy. Okay, but at this position, you can see there is a height from the reference line here. So the height is X plus dengan, ini saya tak tahu. Boleh je awak nak letak apa-apa kan. Letak apa ni? Y. Tak tahu ketinggian tu berapa. Jadi soalan minta kita kira lah, how high above its original position will the ball fly? Okay, setinggi mana daripada original position, daripada sini lah. Maknanya daripada sini sampai sini, X plus Y. Okay, so we can use conservation of energy. Okay, dekat gambar pertama kita ada elastic potential energy. Gambar yang kedua kita hanya ada gravitational potential energy. Okay, ini yang kita nak carilah. H. H besar ni. This is our objective. We want to find what is the value of H. Okay, so half kx squared equal to mg capital H. H tadi tu y plus x lah keseluruhannya. Therefore, you can find. Okay, kita masukkan semua nilai dia tadi. And the mass is 0.3 times H. Alright. So, therefore, you can get the value of H. It is 3.63 meter. Okay, so this is the answer. Okay, 3.63 meter. Alright, so finish question 4A. Next question 4B, the last part. Alright, so here we have a 1990 kg car accelerates uniformly from rest to a speed of 17.1. So u is equal to 0. And then the speed is 17.1. Okay, the time is 4.21 seconds. So determine the instantaneous power delivered by the net force to the car at t is equal to 2 seconds. Okay, so actually we can find the acceleration. Okay, the car is accelerate. So it's moving to the right. So kita boleh kira F net dia lah, equal to MA. So kita perlu kira dulu acceleration. Sebab dia kata dia accelerate uniformly. So instead we can use V minus U over T. Okay. So acceleration is 4.06. Okay. Okay. So kita kena tahu berapa. What is the velocity? Okay, what is the velocity at T is equal to 2 seconds? Kita tak tahu. Dia accelerate uniformly. But at T is equal to 2 seconds, what is the velocity? So we can calculate by using this equation. That's why we need to calculate what is the acceleration. Okay. So U is 0 plus, saya gunakan hijau lah. Okay. V is, V is kita nak kira lah this one. 0 plus A is 4.06. And T is 4.21. Sorry. T dia adalah 2 second. Okay. So V is equal to 8.12 meter per second. Alright. Therefore, okay, since V is equal to 8.12 meter per second, so we can calculate what is the instantaneous power, which is F net times V, same direction, right? So cos 0. Okay. Maknanya bila dia bergerak ke kanan tu, dia mesti ada daya bersih dia. F net. Okay. Where F net is equal to MA. Okay. F net is equal to MA. Okay. So kita boleh tulis MA V. So the mass of the car times the acceleration times the velocity at T is equal to 2 seconds. The instantaneous velocity, 8.12. Therefore, the instantaneous power is equal to 6.26 times 10 power of 4 watt. Okay, so this is the answer. Alright, so we finished discuss all the questions. Okay, so I think for the next video, I will upload about chapter 5, iaitu circular motion. Okay, so hope you still on your track. Okay, you still focus on your study. Okay, and good luck for your UPS 2. Okay, maybe this week or next week. Okay, make sure you score your PB. Okay, and then that's all for today. Alright, see you in the next video. Assalamualaikum dan selamat sejahtera. Bye-bye.